Hi everybody, well my new methodology kind of failed on me. So what we were looking at before for the particle diagram, we had 10 H2O2s and we wanted to take this to the halfway point. So halfway point would be minus 5 H2O2s, which would leave me with 5 H2O2s. And then looking at my balanced equation, if 5 of these reacted, I would get 2 of those, right? 2 MNs, stoichiometric ratio. So I'm going to look for 5, 1, 2, 3, 4, 5, and 2 MNs, and that's the right one. Okay, good, good, good. D, determine the molarity of hydrogen peroxide if 5 milliliters of the sample requires 7.98. Okay, so we're going to do XMV equals XMV. Now notice we didn't use, these aren't clearly acid kind of things. So what we have is we want to find the molarity of the hydrogen peroxide. So we got to look up here. Hydrogen peroxide is this. So remember the X is the other coefficient. 2 times the molarity of the hydrogen peroxide, which is what I'm looking for, times the volume of the hydrogen peroxide, 0.005. Really common mistake here, okay? This is 5, not 50, okay? Equals, so now I'm looking at MnO4. So MnO4, the other one's coefficient is 5. That's going to be the X. And the molarity is 0.15. And the volume used is 0.00798. So my molarity is 5 times 0.15 times 0.00798 divided by 2 divided by 0.005 and 0.5985. And I'm going to change that, and that's going to be molarity of H2O2. But I got to check my sig figs. So 3, 3, 2. So that means my answer should have 2 sig figs. So my real answer would be 0.60 molar H2O2. Okay, and that's it. All right, acid and base reactions. Find an acid. An acid in AP chemistry is an H positive giver. Define a base, an H positive receiver. Define amphoteric, substance that can act as an H positive giver or H positive receiver. Typically, it has an H, and then it will have a negative charge, right? So the H says, I can give this. And the negative charge says, I can receive a positive. So HCO3 negative is an example of one. Okay, water is another one, right? So water, H2O, can give or can receive one and become H3O positive, and water can also give one and become OH negative. Okay. All right. What is an acid-base conjugate pair? How do you identify an acid-base conjugate pair? An acid-base conjugate pair is the acid gives an H positive in solution. The conjugate base receives an H positive in the reverse reaction. Okay. How do you identify it? They differ by an H positive. So here's an example. So if I have H2O and H3O positive, this would be my acid, this would be my conjugate base, because this gives an acid and becomes water. If I had H F. This would be my acid, and the conjugate base is what it turns into. It's going to be F negative. This is my conjugate base. So we'll see these reactions and it'll make more sense to it. Okay. So identify the acid, base, conjugate acid, and conjugate base in the following. Okay. So an acid gives an H positive. So if this gives an H positive, it's going to turn into Cl negative. That's my acid. Now what the acid turned into is the conjugate base. So let me show you how this works for the conjugate base. In the reverse reaction going this way, Cl receives an H from here and makes HCl. Okay. If HCl is an acid, then the other thing has to be the base. So the base receives an H positive. So H2O plus H positive equals H3O positive. Booyah, I see that. Okay. And what the base turns into is called the conjugate acid. Okay. So just to emphasize again, in the reverse reaction, this is the conjugate acid. It's the acid. So if it's an acid, that means it's going to give its H positive, and it's going to turn into H2O. And lo and behold, on the other side, it's H2O. All right, so I'm just going to mark these off. This is the base. It receives an H positive. This is the acid. Water gives the H positive. When water gives the H positive, it becomes the conjugate base. And this is going to receive an H to turn into that again. This is the conjugate acid, because in the reverse reaction, it gives the H to water, right? And turns into NH3. So acids, remember, are H givers. Bases are H receivers. And the word conjugate only means it's on the right-hand side. Conjugate, acid, and base. And notice it doesn't matter what order. It doesn't have to be acid and then base. It could be base then acid. That's it. I better leave that on there. I better erase it because that doesn't even look like a word. Stay there. Yay. Nope, it didn't. That's okay. Here's another one. Okay, remember how I said a lot of bases are RNH2? This is not RNH2, it's RNH negative. Oh, so let's see what happens here. HCl, that screams out I'm a strong acid. And if it's a strong acid, it's going to give its H over here. So if it gives an H, it turns into this. Okay. So this is the acid. So this is going to be the base because it receives an H. And over here, this guy over here has to be the conjugate acid and the conjugate base. Remember, bases receive H's. Cl negative receives an H and becomes HCl. Conjugate acids act like acids, so it's got to give up one of its H's, and it becomes CH3NH negative. All right. What is a sign that the acid base is stronger than the conjugate acid base in the chemical reaction? Okay, so what is a sign that the acid base is stronger? So the stronger one, so the stronger acid has a lower concentration. Remember, concentration can be shown in brackets. The stronger base has a lower concentration. And why is that? If I'm a very good acid, let me take my deep breath here. If I'm a very good acid, that means I give my H up. I'm going to do this 100% of the time. Remember how it's a strong acid? So that means I'm going to be 100% Cl negative, right? Uh-oh. I think it wants me to put a header. I refuse. Okay. So that's how you can tell. If the acid base is stronger than the conjugate acid base, to which direction does the reaction mostly proceed? If the acid base is stronger, it will proceed to the right. Whoops. No, don't do it again. Now I've got another. Okay. If that is stronger, which direction proceed to the right? Remember how I said we have a lower concentration and a lower concentration. So what is a sign for that? So the stronger acid has a lower concentration. Weaker acid has a higher concentration. And remember, in brackets means molarity. Weaker base. And remember, the only difference, the conjugate just tells you what side that it's on. It doesn't mean that it's stronger or weaker. So the direction proceeds most of it right. What is a sign that the acid base is weaker than the conjugate acid base? Didn't I do that already? Oh, but stronger. So if it's weaker, that would mean the acid, oops, that's what I get for trying to keep writing. Acid, concentration of the acid and concentration of the base is greater than the concentration of the conjugate acid and the conjugate base. If the conjugate acid base is stronger than the acid base, which direction does it mostly proceed? It would be left. What is a neutralization reaction? It is an acid plus a base, and it yields water plus a salt. I want to remind you that a salt is an ionic compound. What is a net ionic reaction for any strong acid-base reaction? H positive plus OH negative. Remember, this is the acid part. This is the base part. It makes H2O. And the reason why, I'll give you an example for it. HCl plus NaOH, right? So if I did this is a strong acid, H positive plus Cl negative, plus a strong base, Na positive plus OH negative. And what I would get here would be water, H2O, and salt, NaCl. But remember, this would be aqueous, so I would write it as ions. So it's going to give me water, which I hold together, plus Na positive plus Cl negative. And then I would cancel out my common ions. That's it. What are the signs that a chemical reaction is an acid-base reaction? So what you have is you have an acid, well, okay, so you would have substance starts with H or ends in COOH. Now they could be conjugates. Reacts with a metal hydroxide or any molecule that's NH2. Okay. Other things, this is weird because there's a bunch of things. Products are water and an ionic compound, which is a salt. Write neutralization reactions for the following reactions, then give the net ionic equation. Identify the acid, base, salt, and water. Note NH3 is a weak base and HC2H3 is a weak acid. Since they are weak, they do not break up completely, and some molecules are left in solution. We've been working on that. So this is going to be HOH, which you can write as H2O, plus NaCl. That's the first one. So write the neutralization reaction. So boom. Then write the net ionic equation. Right? And now I know this is going to turn into ions, so I'm just going to do H positive plus OH negative yields H2O. And I note, even though I didn't get rid of it right away, the Cl has nobody to react with. So it's going to be left out. Identify the acid, the base, salt, there's water, and salt. All right. So here we go with this one. I'm going to get, again, HOH plus, I'm just double replacementing this, right? Switching the first ones. Na2SO4. Okay. So I just want to point out this is going to be aqueous. Well, it's going to be, come on, you can erase for me. It's going to be aqueous because this is Na, right? So this is my salt. This is my water. I don't know why I'm writing it as HOH. I guess it emphasizes that it's H and OH on there. I shouldn't. It's very childish to do that, but it's very good to think of it that way. And then acid, base. All right, so where do we go? Oh, same. H positive plus OH negative yields H2O. Good. That's it. By the way, oops, let's put those back on to where I had them. Good. The reason why I ionize my acids and bases so far is they're both strong. Strong like a bull. All right, this one's not strong. This is a weak base. Weak. Okay, so I'm going to have NH3 plus HCl. Now, remember when I told you that it's kind of handy sometimes to think of NH3 as NH4OH? And remember, water's everywhere. So if I think of NH3 as NH4OH, my life becomes easier. So that means that I'm going to get H2O plus NH4Cl. Isn't that crazy? All right. So NH3 is my base. This is my acid. I don't want to erase it. This is my water. This is my salt. This will be aqueous because it's not acting as a base anymore. It's a salt. It's an ionic compound. So that means if I were to write this together, I could write, I'm going to write both of them, NH4OH plus H positive is going to give me H2O plus NH4 positive. Okay, so notice this is together because it's weak. If I kept it as NH3, which is okay, but more confusing, and did this with H positive, then I would get NH4 positive, and that's it. Okay, so both of those are okay, but this, it's hard to show the water on here. So do you see why it is oh so advantageous to think of NH3 and NH4OH as your parents and Santa Claus? All right, so here I'm going to have H2O plus NaC2H3O2. And again, this is going to be aqueous, so the sodium's going to make it fall out. So my net ionic reaction here is going to be HC2H3O2. I write it together because it is weak sauce, plus OH negative yields H2O plus C2H3O2 negative. Define oxidation. Oxidation is loss of electrons. Reduction is gain of electrons. And again, I say oil rig. Oil rig. Cool. How can you identify a substance that has been oxidized? The charge, if it's oxidized, it loses electrons, goes up, or becomes less negative. How can you identify a substance reduced? Charge goes down, or becomes less positive. How can you identify a reduction-oxidation reaction? Everybody calls them oxidation-reduction, but this is reduction-oxidation, same thing. Oxidation numbers change. And an oxidation number is essentially a charge. Where are the electrons located in a balanced oxidation half reaction, a reduction reaction? So an oxidation loses electrons, has electrons as products. Reduction has electrons as reactants. What are the rules for applying oxidation numbers? Elements, it's weird noise, equals 0. Oxygen equals -2, except peroxide, O2 -2. Hydrogen equals +1, except, and these exceptions are very rare, NaH has H is -1. And then the last part is trust, outside of periodic table more. I don't know why that S is traipsing around there. Determine the oxidation number of the atom listed below. Okay, so I know oxygen is -2. So 2 -2s are -4. So carbon is +4 to neutralize it. S and S -2. Well, it tells me that S is -2, so S is -2. S and S solid, so that's its regular state. So that's going to be S equals 0. Okay. Now, as a weird little note, and they use this sometimes, S8 is its natural state. P4 is its natural state. And then I think you know Hunkelbrief should be diatomic. And you should know S8 and P4 are pretty common weirdos. Okay, so just be aware. So oxygen here, each oxygen is -2, so there's -8. So X minus 8, whatever sulfur is, equals -2. So sulfur has to equal +6. 6 minus 8 is -2. S and SO3 -2. So I have 3 -2s, that's -6. So sulfur, whatever it is, X minus 3 equals -2. So X sulfur here is +4. Mn and MnO4 negative. So I have -8 for -2s. So X minus 8 equals -1. So Mn equals +7. And you should put the plus would ask for the oxidation number. There you go. For the following reactions balance, write the net ionic, determine the oxidation states of all species in the net ionic, determine the reaction is redox. Okay, so balance first. 2, and that's balanced. Okay, so this is making weird noises, so I'm going to stop this one. It's a good place to stop, and I'll say toodles.